let's go with it real quick here. So far, as long as you can make a 30, 60, 90 triangle, right? Or 45, 45, 90 triangle in whatever quadrant, you're going to get exact values, right? That's the whole point, trying to get exact values. And so, dun, 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 what happens if you cannot make a triangle? I don't know. It's not trigonometry. So now the question is, guess if we have a 270-degree triangle or angle, do we know the exact value? Because that's what we want, right? We just want to know the exact value. Oh yeah, hold on. So this one is a multiple of 90 degrees, and this one is called, remember we had a funny word, I think it's called a quadrantal angle. You guys remember that? Tell me, what is a quadrantal angle? It lands on, yes, cool, one of the quadrant side lines or one of the axes, right? Perfect, Maddie, yep. So if I make this guy, I make my little curvy line here with my arrow, and I'm going to say, is that 270 right there? Does it matter where I put my dot? No, could be at like, let's see, what's some choices here? Some choices are 0, -5, is that right? 0, -1,000 million 500 googolplex times 4. Yeah. Or we could just make it 0, -1. I think I'm going to go 0, -1. Oh, so yeah, so these guys are not triangles. You can't form a triangle. We can't form the 45, 45, 90 triangle. We right into the normal the way we did it with the 150 and 135, right? We're trying to find the 6 trig ratios, the exact values of the 6 trig ratios. Correct, yeah. So let's go with the questions here. So if this was 280 degrees, there's no way to find the exact value of those coordinates. Good? It's going to be an approximate value. If it was, let's kind of go real quick here. Let me draw some stuff here. So if it was 290, But if it was 300, you guys talk to me. If it was 300, would that form a 30, 60, 90 triangle? Yeah, so because of my 30, 60, 90 triangle, I can, right, find the exact values of the coordinates. Because that's what I'm trying to find. I'm trying to find exact values of coordinates. Karis, does that answer your question? Correct, yeah. So that's why these guys are called quadrantal angles. No, you cannot form a 30, 60, 90, and you cannot form a 45, 45, 90 triangle to find the side, but you can still find the exact value of the coordinate because they're on an axis, right? And we can go as far away from the axis as we like or as close as we like. We just like r equals 1. That makes sense. Does that help, Karis? So the whole goal is find the exact coordinate, right? That's it. Okay, Karis, tell me real quick, does that help out? Does that make sense to you? Yeah. Okay. So here it is. Let's go with it. 270. I need to know each of these for 270. All right. So think, oh yeah, that's right. You got to take out your notes. You might have to take out your notes. You might have to go back all the way to your definitions for the functions here. And you know what? I forgot to print out these notes here. So let me do this real quick here. As you guys are doing that, can't give you guys the answers. No way. I wonder if I have. Oh, I do have it. Come on. 1 second. Got to find something real quickly here, and then well, I think I have it here already. I just did not print it out yet. Yes. Come on, slow computer, let's go. Taking up class time here. In fast mode, here it is. And to G, and I think you guys have probably already done it. Down the list here, and then you guys tell me what is sine. It's -1 over, my equal signs here. -1 over 1 technically, right? But we get ourselves -1. Cool, cosine. 0, 1. Just 0, yep. Tangent. Oh, that is weird. Okay, so these trig functions actually sometimes can be undefined. So instead of writing it out undefined, you could just write UND. There's your. So can't divide by 0. There's no such thing as dividing by 0, so therefore there's that. Okay, cotangent, though, is going to be 0 over -1, or just 0. All right, how about secant? Oh, that's right, huh? Because secant, okay, got it undefined. All right, it's 1 over 0. It's the r value, which is 1, over the x value, which is 0. And then cosecant gets me a 1 over -1, or -1. Okay, you guys talk to me. What do we notice about, let's see. Oh, yeah, tangent, cotangent, right? These guys are reciprocals of each other, right? Aren't these guys reciprocals of each other? Cool. Okay, and then these guys. So if you have a 0, the reciprocal of 0 is going to be undefined, right? And the reciprocal of undefined is 0, and then reciprocal of -1 is still negative. Cool. Gary, question. Oh yeah, that's a good question. Technically no, because we exhausted all the different ratios of a triangle, right? There could only be 6, right? Oh, interesting. Okay, so let's go off of a. Can we go off a deep end for a little bit? Okay, but Adrian, go ahead. Your question. Interesting. Yeah, that'd be cool. We'll get there at 1.5. Okay. So yeah, we'll get there. Okay, so to go to Garrett's question is there other trig functions? Yes, let's go with it just to deepen. So instead of forming a triangle, what we do is we form, oh, you guys remember this from Mr. Grant's class maybe? You guys tell me what this thing looks like. Oh no. Starts with an H. Hyperbola, okay. Hyperbola. And then so we have this little guy right here. We have a length that goes from here. We good? And a length that comes back to, I think it's, if I remember correctly, it's back to here. There's your, right? It's not a right triangle, huh? No. But we have something called the hyperbolic trig function. And so we have sine hyperbolic. And then we have cosine hyperbolic, or we actually say hyperbolic sine. Hyperbolic cosine. So instead of being off of a triangle, it's off of a hyperbola. So no, the only thing that would make sense is hyperbolas. We can't do it with ellipses. That doesn't make sense. Yeah. Now, if you think about it, remember we were going around. Oh, it's so interesting. Hold on. So remember we're making 30, 60, 90 triangles. We're making 45, and we're making 60, 30, 90 triangles, right? And we're making these guys here, right? So are we okay with this? We're making. So I'm talking too fast. Here's my 270s down here. Is that right? So then if I go here, my 60-degree angle here, my 45-degree angle, my 30-degree angle, and I'm back to 0, right? What do those dots look like if you connect them? Okay, so really what's happening here is our trig functions are based upon a circle, and then our hyperbolic functions are based upon a hyperbola. So we have two of the conic sections that we've designated as that. Okay, so that's cool. Yep. Okay, so let's jam with it here. But good question. Good question. Hold. Do you have another question? Okay. All right. Let me get rid of this stuff. How come my toolbar is up here? That's so weird. Okay. So let's do this here. Let's compare functions to each other. So you tell me. This is gonna be a little bit of a tricky one. And sometimes it's like students just get it right off the bat, and students like kind of struggle with this here, okay? Because it's now comparing stuff. So write that down. Think about it. Talk to the person next to you. Say, is that true or false, and why? All right, so there's kind of two different ways you can compare them. You can actually get the value itself. Just get the value. Like you find out what is sine of 30, cosine of 45, and you compare the values together. The other part is just trying to think about it in terms of the coordinates on a coordinate system here. So let's take a look at both here. Let's see which one works here. The easy one here. Anybody know what is sine of 30 degrees? Did we go here? We go like this. We go like this. There's my 30. And then this guy, yeah, opposite my 30 degrees is always 1/2. Is that right? So 1 over 2. So this could be 1 over 2. That's one way to do it. And cosine of 45 degrees. So I'm going to make two triangles. This guy's going to be, it's a, oh, you know, it's a 45-degree angle. You know, both, they're going to be both the same. Is that right? This is what, root 2 over 2 or 1 over root 2? And we're in quadrant 1, right? So it's all positive in quadrant 1. All right, you guys talk to me, and then may have to get a calculator out maybe. But tell me, what is root 2 divided by 2? Is that bigger or less than 1/2? I should say it the other way. Is 1/2 bigger than root 2 over 2? So this is exactly 0.5. It's okay. And this is approximately, right? Approximately 0.707. Is that right? All right, so this guy is false. Are we good there? So you have to complete it and then have to say it. Okay. Another one. Should we try another one here? So it makes you compute it. Let's see if I can write it underneath here. Skip that for now here. I'm going to skip that for now. Let's go with this one here. You guys tell me here. I'm going to move that false there. All right. All yours for this one here. Why do I have the toolbar showing? Thank you. There it is. Now it went away. Okay. So all yours. Tangent of 45 degrees and then sine of 30 degrees. And you've built out your triangles already over there, right? So that's cool. Oh, sine of 30 degrees. We already did that, huh? So that goes 1/2 right over here. That's cool. Oh, tangent of 45. So go over here. We already built this triangle here anyways, right? Already built that one out. So what would be the y value over the x value? Just 1, huh? Okay. How about just a 1 over here? And this guy's 1/2. True or false? And again, it's false here. Okay. Okay. Are we good there? So there's the whole point of comparing them. So then let's talk about this one here. So notice in quadrant one, right? In quadrant one, because the x coordinate is positive and the y coordinate is positive, isn't it true that all the trig functions will be positive in quadrant one? Is that true? So then if you go to quadrant one. If you go to quadrant two, which trig functions are going to be positive in quadrant two? So let's do that on the next slide here. So we're just trying to get the signs correct on this stuff. So here's what we got to do. In which quadrants are these trig functions positive? So quadrant one, oh, that's easy. We're going to write like this. Is sine positive in quadrant one? Yeah, because it's positive, positive. Tangent is positive. Yep, everything is positive because quadrant one consists of all things positive x and positive y, right? There's never you can get a negative anywhere there. Okay, quadrant two. Quadrant two says my x coordinate is negative and my y coordinate is positive. So tell me which functions, all of them, some of them, which ones are positive in quadrant two? How come sine? Yes, r is always going to be positive, right? So the only issue is which one's using the x, which one's using the y. Okay, cool. All right. So Olin says sine, I agree. Any other one? Think back to your definitions if you need to. Which one would involve a r and a y? Cosecant, perfect. Okay, so then the tricky one. Okay, quadrant three. This guy has both a negative x and a negative y. Which trig functions are going to be positive in quadrant three? How come tangent, Adrian? Perfect, yeah, it's y over x, and negative over negative is a positive. Perfect, tangent and cotangent, awesome. And then the last one here, let's see, this is going to be positive x, negative y this time. Which one is, which trig functions are positive here? Perfect, cosine and secant, they already agreed there, right? Because that one has to deal with the x coordinate, so any x's connected with any r values. So I think like quadrant three is the tricky one, right? Because you don't think of it being a negative and a negative. But not tricky for us because we're cool like that. Okay, so we did the basic stuff, we did the angle stuff, that's cool. We did when it's positive, negative, that's awesome. So now let's do this here. Let's find, if we know one trig function or we know two trig functions, can we get the rest? That's what we want to do next. So exercise 3, here it is. Find the remaining trig functions if we know this to be true. And I'm going to do this here. I'll let you guys copy down the problem. Good, good. Copy down the problem and talk with the person next to you. The thing that I want to know is which quadrant are we in? That's what I want to know because that's the important stuff. Because we're going to build our triangle based upon this. All right, so hopefully talking with the person next to you here and decide which quadrant are you in. And sign value is below 0, right? All right, let's show of hands here. How many say we're in quadrant 1? Okay, boom, hands down. How many say quadrant 2? Hands down. How many say quadrant 3? Of course. No takers. Okay, and how many say quadrant 4? Okay, let's think about this here. So secant on your chart, find where secant is positive. It's in quadrants 1 or 4, is that right? All of them are positive in quadrant 1. Yes, you can take your answer back. Absolutely. We are in quadrant 4. We good? The alligator messed us up. Oh, man. Okay. So also note, it's interesting too because we don't have an. Oh, this is weird. Check this out, guys. We don't have an angle that we know, right? We just know a trig ratio, right? So I have no clue what this angle is. I just have a trig ratio, and then I got to do this here. I got to do my swirly. I got to do my swirly line. We good? Like this? Don't forget this guy. And well, technically, hold on real quick here before we do that. We actually don't know the rotation, right? I'm going to take that back. We good? Erase. People with pins, I'm so sorry for you. I don't know which rotation we took to get over there, right? It could have been we went positive, could we went 3 rotations, right? We could have been negative, right? We don't know. We just know that right there. Okay. But I do know a few things here. You guys tell me, anybody know what R is, X or Y? Awesome. X is 12. Okay. Can I know or do I know what Y is?
Yes.
It's a negative something. Perfect. Okay. Ooh, it's a trig ratio. Maybe. Yeah, could be. And I'm going to do this here. You know how we have a little triangle that says a squared plus b squared equals c squared? We could do this. In trig, we can do this here. We can do x squared plus y squared is equal to r squared. Are we good there? Is that true? Right. Now, the only thing is I'm using these guys as distance for now, and then I'm going to change it into a coordinate. Good? So kind of just be mindful. I'm not using the negative of it yet. So I know this guy to be 12. That's good. I know this guy. I don't know this guy. Never mind. I know this guy to be 13. Sometimes you can put parentheses. You don't have to do it all the time, but I got myself a 144. Are we okay there? 169. Subtract 144 from both sides. I got myself a 25. And I'm going to take the square root of both sides. And when I do algebra, because algebra is cool, I have to put plus or minus. Is that true? So y for us could either be a plus or minus 5, but which one do I want? I want the minus 5. Based upon that, can you now give me all the remaining trig functions? So the only one I do know is secant. We good? So I need sine, cosine, tangent, cotangent. I can skip secant. I already know it. I jump to cosecant. All right, so let's go with it here. Hopefully did it here. Look with the person. If you've done, check with the person next to you as well to see if they got the same answer. Don't do that on test days though, okay? Don't want to do that. Okay. All right, I'm going to go with all slides and here's our. Okay, anybody with sine? What's the sine value? -5/13. Good, good. Cosine. Anybody else? 12/13. Perfect. Tangent. Perfect. Okay. And I see some people writing here. That's okay too. No problem on the writing here. Just want to make sure if you are And just go back in your notes to make sure that makes sense to you, okay? Do you guys remember, like, it's so interesting, because I'm in education all the time, right? We talk about how people learn, right? So elementary school, aren't we like sponges, right? We just learn everything, right? Like everything sticks to us. Well, maybe. Okay. And then about middle school, we have this transition period where like we're trying to make sense of stuff, right? And then what happens in high school, normally, typically, developmentally, right, is that after that stage of middle school, things that stick to us actually have to make sense to us now, right? So elementary school, everything's stuck. Now it actually has to make sense. If it doesn't make sense, usually it won't stick in our brains. So on notes, if you guys are just writing it down, please take the time to go backwards and make it make sense in your mind. That's the way it's gonna make sense overall. Okay, anybody cotangent? Okay, let's go with it. Negative. Now it's 12 over -5, right? So the only thing here with the -5 on the bottom, we don't ever let a negative stay in the bottom of fractions. So you have to either stick it in front of the fraction or you're going to stick it on top with the 12. You got to do one or the other. So notice on tangent, the negative is with the 5. On cotangent, the negative is in front of the fraction. Those two make sense, but we don't ever leave negatives on the bottom of fractions. Okay, and cosec, right? Say again. No, it's kind of like the way we speak. We say, hey, that's a -5/2, or it's a -5/12. Notice I'm using the word negative first, right? Because I want to indicate the value of it first, right? So then we don't, in English, we don't like to say 5 -12s, right? It is, right? You want to indicate the value first and then the number. Okay, let's jam. Next one for you guys, all by your, whoa, can't do that. So can you guys do this problem all by yourself all the way through? If you're stuck, you can check with the person next to you, good? If you get stuck, maybe check with the person next to you in regards to which quadrant they have, and hopefully you got it right. All right, as a class here, real quick here. So give me the quadrant that we are in. We're in 1, absolutely. Sine is positive and cosine is positive. That only happens right here. So now I have, let's see, I have R values 2. So notice on this one, I don't get to pick the R value, right? Remember how sometimes whenever we're given angles, we can say R is equal to 1. If we're given ratios already, we just stick with the ratio that's given. Okay, so root 3 is in for the X or for the Y? Or the Y value. So I'm missing X. All yours with some kind of thing called the Pythagorean theorem. All right, give you guys about a minute or so. Finish off the problem, give the remaining trig functions here, look at the person next to, or ask the person next to you, see if they're getting the same answers as you are. If you're not sure, then at least ask to see if you're doing it correctly. All right. The one thing I do want to correct real quick here as a class is that on the I can see. Let me walk around here first. Let's see if I have any things that are come up here. Yeah. We don't know what the angle is, right? We don't know which way you rotated. You rotated left, right? I don't care. I just put theta. No. And then I'm just checking. Okay. All right, class, let's go with it here. So answer, and mostly people got it already here, I think. What did you guys get for x, first of all? 1. Plug that in. Check your answers here. It's 4 minus 3, which is a 1. And we want the positive value of the 1. Is that right? Yep. Da-da-da. And then the rest follows here. Okay. Real quick here, been walking around the classroom. Not going to point out anybody, but when you write the trig functions here, you always have to have something afterwards. So it has to be cosine of theta, cosine of 45 degrees, cosine of 60 degrees. There has to be some kind of unit value. Could be in parentheses if you like, but at least has to be something. Good. Okay, cool, cool. All right, and then I'm going to show the answers here, and you guys tell me if you guys are good. Tangent is root 3 at the end of the game. Cotangent is 1 over root 3, and we're just going to keep it like that. Or if you did rationalize it, you would get root 3 over 3. Are we okay there? Right, you multiply both top and bottom by root 3, and you get a, no, 1 over root 3 and 3 over 3 are exactly perfect answers. I will give them full credit on the test, any one of those. Okay, and that one, a 2 over 1 has to be reduced down to this. Okay, so if you can reduce a fraction, fractions always have to be reduced and simplified. to the degree. There you go. Okay, this one's a fun one here. So 2 over root 3, what's going to be the rationalized answer? Anybody? If you multiply top and bottom by root 3, thank you. So multiplying top and bottom. So this is a correct answer, no problem. To rationalize it here, we multiply these guys together. It gives you 2 root 3 over, this would be 3 times 3, which is technically a 9. And then square root of 9, that's the whole point of doing it, is because square root of 9 is a perfect square of 3. That's the other answer. So that is a correct answer. That's a correct answer. Both are accepted. No problema. Okay, we're good. Don't know. R over Y is good, yeah? No problem. Okay, on your mark is set, go. Think about it. I'll think about it. All right, here we go. Tangent is equal to, oh, this is a tricky one, but you guys can handle it here. So tangent theta is just equal to 2. That's it. And then it says this. It says, and we are in quadrant. Oh, sorry, it should be theta. So theta? What? What does that even mean? Hold on. Oh, that makes much sense here. Hold on. So theta, here it is, right? That's not Q. This should be theta. Theta is an element in 3. And this should be, guys, 2 o'clock in the morning. Sometimes does it for me here. There it is. Now it all makes sense. Okay, so, oh yes, so it is, it's not E. It's like this little curvy little thing like this, right? And then like this little thing that sticks out. And that means an element of. Is present in quadrant 3? Usually it's like this. Like you say 2, right? 2 is an element of the even numbers, right? It's even, not odd numbers, even numbers, right? So you'd say element of, you could say present in, yeah. So that would technically be the same thing because you'd say 2 is present in a set that's 2, 4, 6, right? All right, tricky one, but we go for it here. Messed up on a slide? What? That's crazy. Okay, tangent theta is equal to 2, you guys, and theta is an element in quadrant 3. I had my first mistake ever in mathematics right there. Okay, help me out here. What should we do? Because I thought that trig ratios always had a no numerator and denominator. Whoa, okay, we're way ahead. Okay, so let's go with it here. So I got myself a 2 over 1 is good. We are in quadrant, which one? 3. So if that's the case, we're down here. So what is my coordinate? I go with that. Are we okay with a -1, -2? When we took the tangent of it, it was technically a -1 over negative, sorry, -2 over -1 originally, right? The negatives canceled each other out, and then the 1 disappeared, right? That's what happened there. So now we're kind of reverse engineering it back. Okay, if that's the case, then what in the world is R? I go with that, yeah. 1 squared plus 2 squared, or -2 squared, is equal to R squared, which makes 1 plus 4. Da-da-da, that makes a 5. And we got ourselves, oh, this one, hold on, guys, look at this. For this one, do I put plus or minus? No, R is always positive. It is never, ever a negative. So there's ever no need to put even a plus or minus. Or, okay, I'll do the correct mathematical way. So because we're solving a generic math problem, we do this, but then we decide we have to have R being positive only. Okay. Let's go with square root of 5. All right, correction. My second ever mistake in mathematics. So square root of 5. All right. Okay, so it would good. Can I erase this part here? Everybody got that one ready? Okay, and hopefully you guys are working on the answers already. Some of you guys are done already. Some of you guys are like, Mr. H, can you make this class more challenging? Of course I can. Oh yeah, okay. So let me put in, this is the square root of 5 here. This is a -1, -2. Oh yeah, so let's, yeah. So yeah, this little guy just means present in or element of, or inside. So it says theta is inside quadrant 3. Okay, sine. Everybody okay with a -2 over root 5? Sweet. Or -2 root 5 over 5. Now you write it here. Cosine. Perfect. Anybody give me tangent? Tangent is good. Yep. Anybody give me cotangent? Did we know cotangent before we started this whole entire problem? What should have we done? Flip the ratio for tangent over to 1/2. Perfect. Okay. Technically it's this, but then it becomes this, right? Cool. Secant is good with this. Oh, this one, again, it's a fraction that has to be simplified. So this one on a test, if you do leave it as -root 5 over 1, that would be marked down. We're good? So this one does have to be reduced to a -5. Don't have to rationalize them. And then this one right here, because it's a, yeah, so -√5 over 2. Okay, are we good there? All right, and then we get to the unusual questions. So these are the weird ones here. Always the weird ones at the end. Okay, here's what I got, and I got to move all that stuff over. And let's see if we can figure this one out. What? Fusing algebra and trigonometry together? Put on here? Yeah, put over, yeah, put over here. Ha ha ha. Gotcha. Anyways. Okay, so let's see. Only find sine and tangent. That's all I care about, not the other ones here. Give me sine of theta and tangent theta. If I know this, if the terminal side of theta lies along the line y equals -3x, and we are in quadrant 4. That's what I know. All right, just because of time constraints here, I'm going to do it together with you guys, kind of super quick-ish. Tell me if I'm going too fast, okay? I know you guys have to write it down, so I'll let you guys write it down first, and then let's go with it here. So I got this guy, and I'm going to draw y equals -3x. Anybody remember that from the good old algebra days? Where do we start? At the origin, right? There it is, and then we're going to go down 3. So go 1, 2, 3, down and 1 across. We good? So there's our line. So now we know we're in quadrant 4. Okay, I gotcha. I know a terminal side ends there, so I'm going to start drawing my terminal side. So somewhere I have a dot, is that right? My triangle could be as big as possible, as small as possible. It doesn't matter. But my coordinates, what in the world are my coordinates? Okay, so this one, notice on this one, I don't want r equals 1, right? But I know the coordinates. If I go from 0, 0, and I go down 3, and I go over 1, -3 is perfect. Yep, I know the exact coordinates. Remember, all this stuff is all about, can I find the exact coordinates, right? All right, once that is done, tell me what is r at this point. Perfect, okay. 1 squared plus a -3 squared gives me r squared, whatever that will be. I think that's a 1 plus 9. How about a 10? And how about a square root of both sides gives us a r value of a square root of 10. Whew, I don't have to do all 6 trig functions. That's nice. Just sine and tangent. That's it. You don't have to rationalize. unless you want to, but you can if you want to. So for sine, it's going to be, let's see, it's going to be -3 over root 10. Keep it just like that if you like. But if that just feels like not correct, then you can rationalize it to look just like this. Okay? Both are correct on the test, no problem. All right, what is tangent? -3. Oh, interesting. Hold on. So if, see if this makes sense here. So tangent, if you start off at the origin on a line that's y equals -3x, right? Remember, you're going to go down 3 units and 1 over to the right, right? Isn't this right here down 3 units, 1 to the right? It's the slope. As long as the line is going right through the origin, right? The line is going right through. In fact, there's an application question we actually do all the way in calculus where it looks at trajectory of stuff and you're looking at the 0, 0 marker and you're looking at stuff and then we use tangent for it. Okay, and then the other weird one. You ready for this one? I know you have to take time to write it, so I'll let you guys take time to write it. Go for it. So we're going to find x. X is missing. But I know that the y value is -3. And then I also know the terminal side. Yeah, that's on the terminal side somewhere. But then I also have a trig ratio. Does that help out any which way? I guess that my question is there. And there's a little trick to it. It's going to be a little tricky here. Okay, I'll give you the trick here. Yeah, I think you're looking for 2 answers. Oh, okay, so 3, 4, 5 triangle. So I guess let's try to set this up. Let's see if this makes sense here. So I get x -3 is on terminal side. I'm looking for, okay, so let's do this here. When is the sine value going to be negative? Which quadrants? So sine looks at the y values, right? Yeah, so it'd be quadrant 3 and quadrant 4. True? Everybody agree there? Okay, so I'm looking for this guy, and I'm looking for this guy. So this is -3. That's all I know about that one. Me think, but then I also have to think about this side too. Is that right? Because x could be on both sides. I just know the trig values, trig ratios are negative. Perfect. Yep. So then if that's the case, those are both 5s, and then we also know what is a 3, 4, 5 triangle. Is that right? Yeah. And we get ourselves this if we wanted to. Oh, this is so interesting. Check this out. If we do all the work here, we get ourselves plus or minus 16. And which one do we choose? We choose both. Absolutely. This time we choose both. Because it is true. That statement could be true in quadrants 4 as well as quadrants 3. Okay, guys, we still don't get to 1.2 homework. So, anybody still have questions off of 1.2 homework? Let me do this here. Wyatt, which ones? 37. So I'm going to do this here. I'm going to write it on my little to-do sheet, and I'm going to send a little video about it. Yeah. So don't need to turn it in.
So and then is the entirety of 1.3 now?
Yes, that's right. So guys, we can start the rest of 1.3 now, and it'll be due Wednesday next week. Monday will be questions about it. Wednesday will be turn in if we don't get stuck doing homework. Seriously.